Hello students, welcome to physics class. Today we discuss law of conservation of momentum. Hope you remember in the last session we discussed what is momentum. That is, every moving body possesses some momentum. Momentum of a moving body is the quantity of motion contained in that body, and it is the product of mass and velocity. Now let us see what you mean by conservation of linear momentum. Here we have two body A and B. Say their masses are ma and mb. They are moving with the velocity ua and ub along a straight line. Say if ua is greater than ub, this is the body A and this is the body B. A having a velocity ua and B having a velocity ub. ua is greater than ub. Both are moving along a straight line. So we can expect after some time they will collide each other. Say after some time A and B, the body A and B collide each other. You know, during the collision, A will exert a force on B and B will exert a force on A. We studied from Newton's third law, every action having an equal and opposite reaction. So A applying a force on B, that we wrote as FBA, force on B due to A, FBA. And similarly, B applying a force on A, that we wrote as FAB, force on A applied by B, FAB. FBA is the force on B applied by A. And you know that the forces are mutual, so they will equal and opposite in direction. The force on B is in this direction, force on A just opposite of that. So during this collision, the collision lasts for a time t. Say the collision is last for a time t, and after collision A will moving with a velocity va and B is moving with a velocity vb. That is, final velocity of A and B are va and vb respectively. What is initial velocity is ua and ub. So you can say what are the momentum of the body before and after collision. What is the momentum of first body? We can write as ma into ua. Before collision, the momentum of first body is equal to ma into ua. Momentum of second body is equal to what? mb into ub. That's the momentum before collision. What about the momentum after collision? This one having a momentum of ma into va, and this one having mb into vb. That's the momentum after collision of A and B. Now we are just calculating what the rate of change of momentum of A. What do you mean by rate of change of momentum? Change in momentum in unit time. That is, change in momentum divided by time. That getting the rate of change of momentum of A. The rate of change of momentum of A is equal to the final momentum of A. What is final momentum of A? MAVA minus initial momentum of A. Initial momentum of A is MAUA. That is MAVA minus MAUA divided by T, because the collision is taking for a time T. So MAVA minus MAUA divided by T measure the rate of change of momentum of A. But you know that the rate of change of momentum is numerically equal to the force acting on A. This is the rate of change of momentum of A, which is equal to the force acting on A. How can you write the force acting on A? FAB. The force applied by B on A. That is FAB. Now, the rate of change of momentum of B. The rate of change of momentum of B. That's equal to final momentum MBVB minus initial momentum MBUB divided by T. So that's the rate of change of momentum of B. That's numerically equal to force acting on B. Who applying force on B? During the collision with the A. FBA is equal to MBVB minus MBUB divided by T. That measure the rate of change of momentum of B. Now, according to third law of motion, force acting on A and B are numerically equal but opposite in direction. So we are writing the force on A is FAB and force on B is equal to FBA. They are equal. They are equal. And this minus sign shows that they are opposite in direction because the direction of FAB is this one and FBA is this. So they are equal in magnitude. This minus sign shows that they are opposite in direction. Now substitute A, that is force FAB and FBA. This is FAB and this is FBA with a minus sign. Okay, FAB is equal to MAVA minus MAUA divided by T is equal to minus FBA. FBA is equal to MBVB minus MBUB divided by T. Now T is there on both sides. We can cut the T. T on both sides is cancelled. Now we can write as MAVA minus MAUA is equal to, we are removing this bracket with a minus sign giving as MBVB minus become positive, that's plus MBUB. Okay, now rearrange this equation. We are taking this minus MBVB to left side and this minus MAUA to right side. Rearrange like this way. That is MAVA plus MBVB is equal to MAUA plus MBVB. Now let's see. This is what? MAVA. This is the final momentum of A. MBVB. This is the final momentum of B. So this actually measures the final momentum after collision. Final momentum after collision. Total momentum after collision. This is what? MAUA. This is the momentum of A before collision. MBUB. This is the momentum of B before collision. So this is the total momentum before collision and this is the total momentum after collision. So what you are getting is the total momentum before collision is equal to total momentum after collision. When no other external force is acting in the situation on the system, when no external force is acting, total momentum before collision is numerically equal to total momentum after collision. That is, momentum is conserved. The total momentum is conserved. And this principle or this law is known as law of conservation of momentum. Law of conservation of momentum. Total momentum before and after collision will be same for an isolated system. If no other external force is acting here, the total momentum before and after collision will be same. And so the law of conservation of linear momentum state like this way: when no external force acts on a system, total linear momentum of the system is conserved. It means the momentum before collision is equal to the momentum after collision. This is known as law of conservation of linear momentum. That's all today. Thank you.